All right, so we're gonna come back to the example that I skipped on the earlier handout, which was the question we asked in class, which was under the lighting in Stevenson basement, right? The wonderful room I bet all of you are missing, whether I look my age or not. Right, so what we did was, for all of you that were present in class on Friday, the last day of class in person, I asked you what you thought my age was. All right, so the question I phrased was, do I look my age? And I collected all of your responses from this experiment, and then we saved that response in a file in StatCrunch. So if I go to my groups, 2020 is guess my age file. So the responses that you gave, so all of you in the two sections that show up, are recorded right there. I know, someone thought I was 45. All right, not hurt. All right, but anyway, so what we're going to do is, we are going to ask the question whether I look my age or not. And we're gonna turn it into a hypothesis test and try to answer it. So if I am looking at trying to answer this question here, the first thing I need to figure out is whether I'm going to be using a one mean z-test or a one mean t-test. So the question is, do I know the population standard deviation? Do I know the standard deviation for what everyone thinks my age is? The answer is no. Right, so we're not going to be using the z-test. So in this case, provided everything works out, we're going to probably be using the one mean t-test. So what are the three things we need to verify if we want to use a one mean t-test? Well, the first one is, simple random sample. So, all right, so we have a random sample. The second one is this a normally distributed distribution, or is our sample large enough? Well, we asked 36 students, so my n is 36, and it's bigger than 30, which means I can assume that the sampling distribution of sampling mean formal is approximately normally distributed via the central limit theorem. And finally, we know sigma is unknown, which means we can use our one mean t-test. So the first thing we are going to be doing is we are going to be stating the null and the alternative hypotheses. And the null hypothesis is that, I look my age, so mu is equal to 33. And the alternative hypothesis, if I look at my statement, is there enough evidence to conclude I don't look my age? I'm not saying whether I look older than my age or younger than my age, but I don't look my age. So what kind of test do you think we're going to be running? One left tail, right tail, or two-sided? Exactly, we're going to be running a two-tailed or two-sided test. So it's two-tailed. All right, so the question now is, does the data we collected, does the sample we collected provide enough evidence to reject the null hypothesis that I look my age or not? All right, questions here. So next we are going to ask what significance level we're working at, and the question tells us at 5% significance level, so my alpha is equal to 0.05. Well, step 3, we need to find our test statistic. So t, remember, the formula for t is x bar minus mu naught divided by s over square root of n. And do we know any of these information here? Not really. But guess what? We have the entire data at our hand. So what I'm going to do is I'm going to ask StatCrunch to tell me what the sample mean and the sample standard deviation is. So to do that, we're going to go to summary stats. We're going to do it by columns. We're going to do age, and I'm going to ask for everything here. Compute. So when I do that, I get that the sample mean is 32.611, and my sample standard deviation is 4.121, so 4.12. And the standard error really is the standard deviation divided by square root of n, which is what goes in the denominator, is 0.6869. So let's go ahead back to our there. We found out x bar was 32.611 minus 33 divided by 4.12, which was my sample standard deviation, over square root of 36. So when I do the computation, we're going to get negative 0.566. And so that's our statistic here. Alright, so next up, what we would like to do is we'd like to find the p-value. To find the p-value, what we're going to do is we are going to sketch our image again. And since it's a two-tailed, we're looking for the area to the right of 0.566 and the area to the left of negative 0.566. And we need one more information. The degree of freedom in this case is 36 minus 1, which is 35. All right, so what we could do is we could go to the table and approximate the p-value. So let's go ahead and do that. So what I'm going to do is I'm going to go to the table here, and we're going to go to degree of freedom 35, and we realize the first value that shows up is the area to the right of 1.306 is 0.10. So if I go here, let me change colors. So if I go somewhere here, that number is 1.306. I know the area to the right of that is 0.10. So what does that mean about the area to the right of 0.566? Well, it's bigger than 0.10. Right? So this area is bigger than 0.10. Since this is symmetric about the origin, that area is equal to that one. So that also has to be bigger than 0.10. So if I combine those two, I get that my p-value in this case here is going to be bigger than 0.20. And now we are looking at significance level 5%. So is my p bigger than alpha? If it's bigger than 0.20, is it going to be bigger than 0.05? The answer is yes. So since p is bigger than alpha, don't reject H naught. Right, so what this means is at 5% significance level, the data does not provide enough evidence. Enough evidence to conclude that my perceived age is not 33. All right. So I'm not saying I don't look 33 or I look 33. What we're saying is at 5% significance level, the data does not provide enough evidence to say that my perceived age is not 33. Right? So again, that's very important to make that distinction there. All right, so like we've been doing so far, what we're going to do is we are going to go through this example here in StatCrunch. So let's go back to StatCrunch. I have my table right here. So what I'm going to do is I'm going to do a one mean t-test. So I'm going to go to t-stats, one sample. And since we have data, I'm going to use data right here. So the age is going to be the value we're looking at. The null, my null hypothesis is that I'm 33. We're doing a two-tailed test, and I'm going to ask for a p-value plot. We're going to go ahead and compute this. All right. So remember, when we are doing using table, we're going to have limited information. So we can only approximate our p-value, say it's larger there between two numbers. However, if we use StatCrunch, we can get our p-value, which is 0.5749. All right, so if I look at this table, there's a lot of area here, right? So is 0.5749 bigger than 0.005? Yes, right? So what this means is that since p is bigger than alpha, at 5% significance level, we cannot reject H non. Okay. So again, really what this is saying here, let me emphasize one more time what this p-value is telling us. It's telling us the likelihood or the probability of getting a result like the one we just got, right, based on the sample we had, is 0.5749, provided the null hypothesis is true. All right, so the probability of getting a result like the one we just got is going to be 0.57549, provided the null hypothesis is true. All right, so fortunately,